As I look at this definite integral, I could recognize this as an inverse sine, but I actually wanted to work this like you didn't recognize it to show you, if you don't remember these inverse integrals, that you could get them with trig substitution as well. So I'm going to label the sides of this triangle such that this is one of the sides, so this is going to be 1 and this is going to be x, so that this is the square root of 1 minus x squared. Then I'm going to let sine theta equal opposite over hypotenuse. So my dx is going to be cosine theta d theta. Now I'm going to do a trig substitution, and I had a definite integral, so I either need to change my limits of integration to get them in terms of theta, or do an indefinite integral and then resubstitute. I'm actually going to change them here so we can see how to do that. So we'll deal with those in just a minute, but my dx is going to be cosine theta d theta, and then in my denominator I'm going to have 1 minus sine squared theta. Okay, as far as limits of integration, here is 0, so I come up here and say, when is sine theta 0? And that would be at 0. And then when is sine theta 1/2 or 0.5? And we know that, and we're looking here for sine in first or fourth quadrants, and so that's going to be positive. So in the first quadrant, when is the sine 1/2? And that's going to be at pi over 6. Now let's see what we can do to simplify this. This is Pythagorean identity I could utilize and have cosine squared theta, square root that and get cosine theta, and actually then those would cancel. So I'm just integrating 1 d theta here. So this would just simply be theta from 0 to pi over 6. So that's just going to end up being pi over 6.